Now that we have defined both momentum and impulse, we can look how the two are related. This is also something that Newton has found out, and it comes directly from Newton's second law of motion. You haven't been through Newton's second law of motion because we didn't finish the last unit because of the swine flu. So this first idea of Newton's second law of motion might not make much sense before we discuss Newton's second law of motion in more detail. But for now, just imagine that we have been with you through Newton's second law of motion. And Newton's second law of motion is very simple to understand. Basically, it says that if a force is acting on an object, the object will accelerate. It will not be at rest anymore. It will not be moving at a constant velocity. If a net force, non-zero net force, is acting on an object, the object will accelerate. And the amount of the acceleration given to the object is directly proportional to the force. So the more you push it or pull it, the more it will accelerate. It also inversely proportionally to the mass. So the heavier the object is, the smaller the effect of the force is going to be. So this is called Newton's second law of motion. From here, directly, we can get to the relationship between mass and momentum. Acceleration is defined, of course, as a change in velocity, the rate of change of velocity. So that's this second term in here, the rate of change in velocity. And you can see that if you cross-multiply in this equation, the velocity times the mass is going to give us the momentum of the object, and the force times the time is going to give us the impulse. So this equation basically tells us the relationship between momentum on the left side and impulse on the right side. And so we can say this is not just mass times the velocity, this is mass times the change in velocity. So we can call this quantity the change in momentum, and on the right side, this is not just time, this is the time that the force was acting. So we could call it a change in time. This quantity right here gives us the impulse. So we can say that impulse changes the momentum of an object. And usually when a force is acting on an object, it changes the momentum in such a way that the mass of the object stays the same. Usually the momentum changes because of the change in speed, the change in velocity. You could have a change in momentum because of the changing mass, and in more complicated problems we would have to consider that. We're not going to use such complicated problems in this unit. So when we say change in momentum, we're going to assume that the momentum changed because of the change in velocity. And this is the relationship we're going to be using. Mass times change in velocity equals force times the time.